Okay, section 2.6 deals with scatter plots. Scatter plots are just an arrangement of data that you collect. They're called scatter plots because they don't have to necessarily follow a certain trend in the data. They can be all over the place. They are just the raw data, basically. We like to fit trends to data. Sometimes we plot a scatter plot and it has a positive correlation. We can have a negative correlation. Or sometimes our data has no correlation. So if our data has positive correlation, that means the trend in the data seems to be going in an upwards motion from left to right. Like most of them seem to be increasing. So if I were to fit a line through that data, it would have a positive slope. So that is a positive correlation. If our data has a negative correlation, then the trend in the data seems to be going downward from left to right. Okay, so if I were to fit a line through that data, it would be looking like it was going down from left to right. It would be falling. And then sometimes our data, we cannot have anything that makes this data have anything in common with each other. So if we just have data points that are scattered throughout, you can't really tell if it's going up or down. We call that a no correlation scatter plot. So something else that we can consider when we're talking about scatter plots is something called a correlation coefficient. Correlation coefficient. And what a correlation coefficient does is it just kind of detects like a range about how close the data is to each other or how close it is to fitting a line. So that is a number between -1 and +1. So if the closer the number is to -1 means that we have a negative correlation going on with our scatter plot, and it's a very strong linear correlation, meaning that the data is getting very close to looking like a straight line. Likewise, if our correlation coefficient is a +1, then we have a strong positive correlation, meaning that the direction of the scatter plot is going in a positive direction. It's rising from left to right, and it's looking close to a line. We usually see numbers like -1, -1/2, 0, a +1/2, and +1 to detect what approximately is our correlation coefficient. If a number has 0 for a correlation coefficient, that would be a no correlation graph. So this would be where our book would come handy. So if you'd like to follow along and you have our book, page 114. So if you look on page 114 and look at problem 1 at the guided practice. At the bottom of the page. If you notice on problem 1, it looks something like this. The data is going upward. So if the data is going upward, then it would have a positive correlation. So that means we would look at the right side. But these data points are not very close to making a line. So we would say this is approximately closest to about a +1/2 for the correlation coefficient for number 1 on the bottom of page 114. If you look at problem 2, those data points are actually closer together. They're really close to forming a line. Okay, so it's negative So that means we need a negative correlation coefficient. And since it's really close to forming a line, we would say this is closer to -1. So if it's very close to a line, then it needs to be a -1 or a +1. And it just depends on if it's positive or negative. If it's a negative correlation, it needs to be -1. If it's a positive correlation, it needs to be +1. And if you look at number 3 on page 114, you will notice that this is a no correlation graph, because you can't really tell if it's going to have a positive correlation or a negative correlation, or if it's trying to go up or downward in the trend. So if it has a no correlation graph, then you would say the correlation coefficient is approximately 0. So hopefully this will help you to decide what type of correlation that you have and approximate the correlation coefficient between -1 and +1.